Boss. Thanks for joining us today. Now it's still a bit early. We'll start off our webinar sharp at 11 a.m. If you have any question to ask, please type your question in the chat box. I will bring them up at the end of my presentation, and we also will have some time for the questions at the end. Hi, good morning, everyone. I'm pleasure to see you guys here today. My name is Kevin Zeng. I'm the application engineer at Dassault System. Dassault System is the distributor of MATLAB in Southeast Asia. Today, we are presenting deep learning overview for image and video. Example today is to develop a vehicle object detector to detect vehicle on the road. Just a little housekeeping before we started. If you have any question during the presentation, please type them into the chat box. I will bring them up at the end of our presentation. And kindly remember to mute your mic. After this webinar, you'll get the video via email. Last, tell us how we did in the survey. We appreciate your feedback. Deep learning is a key technology driving the current artificial intelligence mega trend. Its origins date back to the dawn of the computing that evolved to include machine learning. And now, deep learning is a subset of machine learning. The popular consumer applications of artificial intelligence include speech recognition used in the smart speaker, face detection for cameras on phone, and also like autonomous self-driving system in automotive vehicles. You may also heard of some other mainstream applications of deep learning, but how many of them would you consider applicable to the engineering and science domains? One such example is deep learning object detection, which is where a trained deep learning detector will scan an image or video frame for certain objects. It not only finds if the object is in the image, but also draw a bounding box around the object as well. This same technique is being used by oil and gas player Shell to locate the depth location that identify different machinery on the location. Therefore, it facilitates the maintenance engineer to locate the depth to look for the information about like expired date of maintenance. By automating this process, this allows shall to perform more efficient maintenance on their equipment. We are seeing applications developed with our software MATLAB across different industries, such as first, aerospace and defense, where Airbus is performing automated defect detection via a deployed model running on an embedded GPU. Second, automotive, where Tensor is modeling, simulating, and deploying models for their complex engine control system. Third, energy production area, where Shell has developed models for earthquake detection using signal processing and deep learning technique. In research, papers are being published to show MATLAB begin used to, like for example, automatically predict cancer from a complex medical images, or convert the brain waves of ALS patients into the words and phrases. To help you understand how MATLAB developed until today, let's take a look at the MATLAB evolution of deep learning support. Does anyone know when MATLAB first had the ability to train neural networks? The answer is in the mid-90s with the initial release of the neural network toolbox. When did deep learning first come to the MATLAB? A popular framework, called NET, from Oxford Visual Geometry Group, came out in 2014, but MathWorks first officially supported it in 2016. And since then, we have been released a stream of major updates. You may notice that some of these updates relate to the broader area of deep learning. Other like our apps focus on the productivity and some for deployment. Many people will ask, what's coming next in MATLAB? The answer is the field is constantly evolving, and in general, this path is difficult to predict. However, you may see that each year, the number of updates in MATLAB have increased over the year. MathWorks is committed to embrace the growing and the ever-evolving field through our increased development efforts. One item I would like to highlight, especially highlight them out, is that we now have over 200 examples across different domains, different fields that help to serve as a great starting point for users looking to apply deep learning in their area of expertise. Here are the two videos example to demonstrate deep learning capabilities for image and video. The first one is a signage detection on the road using deep learning YOLO V2 version 2. And the second one is a semantic segmentation on the video or image to get the pieces level for the road and the car. So you can see that the road is appear in green color and the car is appear in blue color. Emerging area I would like to tell you is reinforcement learning, which is a type of machine learning that use deep learning. It has been shown that it has the ability to solve some really hard problem, for example, control system, or for example, such as teaching a self-driving car to navigate the traffic, like what the video showing just now. Or train a quadrant robot to how to walk. Reinforcement learning is a very exciting topic to talk about. However, today we are not going to include reinforcement learning in our webinar. If you are interested to know reinforcement learning further, you are welcome to contact our marketing and we are willing to help. Let's understand the workflow before our demonstration. We talk about a deep learning workflow, a simplified views result in the four main stages. The first is a data preparation. So data preparation includes like data cleansing, human insight, and the simulation. If let's say you don't have enough data, then you might need to generate more data. For example, simulation generated data. Second, algorithms and modeling. The model design, the neural network design, and the hyperparameter tuning, and to adopt the GPU computing power to train the model. Third, simulation and testing. Yeah, testing the accuracy of our system and integration with how can you integration with a complex system. And last, ultimately you're looking to deploy into the field, for example, embedded devices, enterprise system, edge, IoT, edge, cloud, and desktop application. So through our live demonstration today, I will walk through all four steps of the workflow and talk about some of the challenges within each steps. Today, you'll be developing a deep learning algorithm that can detect vehicle objects in image and video. For this example, you'll make use of a prominent algorithm called YOLO V2, which stands for You Only Look Once, version 2. This is a particularly a good deep neural network for object detection for a few reasons. It can detect objects in real time, which made it versatile for tasks such as like autonomous driving and traffic monitoring. And it's faster than some other previous object detection deep learning algorithm. For example, our CNN, ACF detector, and etc. We step through the workflow process today, pieces by pieces, and build an application from the ground up that can accomplish the task of automatically recognizing vehicle objects. I believe everyone is agreed. In AI, data preparation is the most panic part that consumes a lot of time. Today, data comes from multiple sensor databases, structured or unstructured, spending time with a different time intervals. Some data are really noisy from different domains and so forth. The data need to prepare for the next stage, the algorithm and the modeling stage, and the data preparation again is really consuming and sometimes really hard. MATLAB and Simulink come into the picture to make the data preparation more effective and productive. And today I would like to highlight is the data labeling. Data labeling is also one of the steps in the data preparation. Data labeling is required for any kind of a supervised learning algorithm. And this can be time consuming and error prone. For deep learning in vision, MATLAB provides data labeling apps like the image labeler app to help you use techniques such as semantic segmentation and object detection. We have other labeling apps as well. We have like ground truth labeler, audio labeler, signal labeler, image labeler, and the video labeler. All of them in GUI, they can generate the MATLAB code at the end for the steps begin done in the GUI. And you can use the generated code for reuse in the future. Now, let's go to the first part of our demo script in MATLAB to see how to prepare the data for the vehicle object detection using YOLO V2. Hi. So now we are in the MATLAB environment. If you are not familiar with LiveScript, let me introduce you MATLAB LiveScript. MATLAB LiveScript allows you to put a title, the table of content, the picture, and together with your coding. And you are allowed to break them into the session by session. Over here, you have the data set in the vehicle images. So basically, these all are the images taken in the road on the road. Let's run this session and open the image labeler and load our image into the image labeler. Other than open the image labeler in MATLAB command, you also can look for image labeler on the tab apps and search for image labeler. Now let's run the first session. Here you go. We have loaded our images into the image labeler through the MATLAB command. So now you can see there are 200 over images in the image labeler. And the task now is one to label the location of the car in the image for our object detection. So first of all, here there's a label signage. We open the label signage, find the new ROI label. So the name is vehicle, and you are allowed to label the image through the rectangle, line, or pixels level for segmentation. So I will select the rectangular here. And simply to draw the box for the car. And this process is really painful because you might need to go through every picture to label the car. However, if you have a well-trained ACF detector, you can utilize the ACF detector help you to automatically label the car in the picture. So over here, there's an ACF vehicle detector trained in different scenario and condition. So it must be not robust enough to detect every vehicle for you, but it can help you to reduce some effort to label for some car in the picture. So let's select some picture to run through the ACF detector. So I select the ACF detector and I click on the automate. And press the run button. You allow the ACF detector to screen through those selected image and help us to label if possible. So let's walk through again the result. Yep, it's correctly labeled. Yep, he didn't label the car. So we might need to label manually ourselves. Yep, the ACF detector cannot detect this car. Let's manually label it ourselves and change our YOLO V2. ACF detector didn't help us to detect this as well. Yep. This begin done by the ACF detector. Yep. That's all. If you accept the result, just click accept. And those selected image has been labeled. Once you complete the labeling for all the image, then now is the time to export the result back to the MATLAB. So you're allowed to export the result, save to the Mat file or back to the workspace. So let's say you're looking to export the result back to the workspace. You are allowed to export the result in the two kind of format. First is a ground truth, second is a table. So now I'm going to select the table and click OK and close the image labeler. Now you can see actually your result is here, which is a ground truth in the table form. Let's open this to visualize the output. Yeah. Over here, you can see the first column indicate the image location, the image file name, and the second column indicate the vehicle label coordinate. You might see some coordinate, some vector is longer because we have more than one label. And start from the image 11, we haven't complete the labeling process. Okay, that's all for the part one. Let's go back to my presentation slide to continue. Now we are moving to the second step in the workflow, the one that perhaps get the most attention, AI-based algorithm and the models. Within the MATLAB environment, you have a direct access to a common algorithms used for classification and regression. For example, in the machine learning, you can see decision tree, naive Bayes, SVM, deep learning, you can see CNN, the GANs network, LSTM, multi-input and multi-output neural network. Reinforcement learning, you can see the algorithms such as like DQN, A2C, TTPG. Regression, linear is the most simple one, or non-linear regression method, or decision tree regression. Supervised learning, example, you can do like k-means, PCA, GMM. Predictive maintenance, you can build the RUL models, less of useful life and condition indicators. And definitely at the end, you can use a Bayesian optimization method to get the optimized value for the hyperparameter for those mentioned algorithm. Definitely, there are more algorithms in machine learning and deep learning. And with MATLAB, you can easily use pre-built models developed by the broader community, such as like LesNet 50 for the classification and the YOLO for the object detection. So for the pre-built models, we have LSNet, GoogleNet, VGG, SqueezeNet, SufferNet, and etc. There are more. Wow. Let's talk about the reference example. Examples are the way a good start for the engineer learn how to use algorithms and find the best approach for their specific problem. We provide a host of examples for building deep learning models in a wide range of domains. As mentioned, we have over 200 examples for deep learning in our documentation. I have multiple times to mention about the apps for data preparation. Now we also provide the apps for second step AI modeling. For deep learning, we build apps that help automate the training step and provide visualizations for understanding and editing the deep networks. We have deep network designer where you can access the pre-trained models, visualize at imported model. You can visualize the parameter at a certain layer and create a, or you want to create a model from scratch by yourself. Analyze the model, the size, the weight, how many parameters inside the layer. Or you can import the data for the classification training and specify the hyperparameter for training in GUI. And at the end, train the model, train the neural network. Once you completed the training portion, you can export the train model and the result, or generate the code that begin done in the GUI for reuse in the future. In the latest release, there is a new app to manage experiments. As we know that AI is a try and error, so we need to do multiple experiments to find the best combination of hyperparameter or neural networks for your own applications. Here's a short overview video highlighting its capabilities where you can explore the hyperparameters, Over here, you try different experiments with a different hyperparameters. Monitoring the training progress. Define experiments with a MATLAB code. Keep track of your work in the trial. And at the end, you can select the best model and export them out. Let me further elaborate experiment manager as shown in the video. AI is about try and error. So experiment manager allow us to try different value of hyperparameter, different neural network, even can try different data set to help us to get the best combination to build our neural network in our application. Talk to us if you have any difficulties to use Deep Network Designer and Experiment Manager. Deep learning training can take a long time. Maybe your personal PC is not powerful enough to train deep learning neural network. Then perhaps you need to find the better computing resources or compute platform. If our cloud support and the third-party integrations, you can move your training, your deep learning training to the appropriate compute platform. It could be a GPU, public cloud, private cloud, and so forth. The point is that a single model in MATLAB can be moved to the appropriate compute platform, saving an enormous amounts of time to train deep learning neural network, and allows you to leverage the light compute technology to accelerate the training. You also know that the broader deep learning community is incredibly active and prolific. And new models are coming out all the time from different framework. For example, today you can see a new model in the TensorFlow, tomorrow you can see another new model in the PyTorch. But MATLAB support ONNS standard. You can access to those new models in other framework and can work with them within the MATLAB environment. To summarize the modeling step, just want to mention that there are a lot of algorithms and methods available in MATLAB, and a lot of GUI application, for example, like image labeler, deep network designer, experiment manager. You can see them in MATLAB, which help you to minimize your effort in coding. And you can accelerate the training to the appropriate compute platform and engage with the AI community through the ONNS. Now let's go to the second part of our demo script in MATLAB to see how to train a model to detect vehicle objects that we care about. Here, there's an example allow you to walk through how to build YOLO V2 in a simple way. But today, I will go deep a bit to talk about how to build a neural network for YOLO V2. Let's come back to MATLAB software. Yeah, so we are going through the parts to train and evaluate a model. Yeah, first of all, we have to load the dataset first. This dataset is what we have prepared with all the label, the coordinate of the vehicle on the image. Okay, so let visualize what do we have in the data set? So over here you got a vehicle data set. So let me open up the vehicle data set. So actually this is exactly what do you see the data, the information exported from image labeler. So this is the image file name and the coordinate of the vehicle. Okay, so you can see this one that there is more than one vehicle in the image. That's why the vector is longer. Yeah, so this is a vehicle data set we have prepared on the demo one. So the next step we are going to do the partition. So we are going to to break the data into the testing data set and the training data set. So you are break into 50% hold out method. That means you are break 50% for testing data set and 85% for training data set. So over here you can see the training data set is around 251 data images, and the testing data set has around 44 images. And the next way you are going to use a function called data store. So the wonderful part of this function is save the location of your image, but don't load the image into the memory. You only load the image into the memory when necessary for the algorithm. So it helps us to save a lot of memory in our RAM to run the deep learning application. So we are going to save our image in the image data store, our label in the box label data store. Then you do one for the training data set and do another one for the testing data set. And at the end, you combine the image chain and the box label chain into the training data store ready for the YOLO V2. Let's export one of the images from the data set to understand the type of the images it contains. So just randomly to read one image and understand what do we have in the image data set. So this is the image that we have that exactly what is seen in demo one. So there's a boarding box that we label ourselves through the image labeler. So this is a car. Now we come to like very interesting part, and I found it's quite difficult to explain directly in the webinars, but I try my best today. So we are going to create a YOLO V2 object detection network. So basically the YOLO V2 object detection network have two sub-networks. The first sub-network is a features attraction network made up of multi-layer of convolution layer. And the second one is detection sub-network. So this is a YOLO V2 detection network. And this is a features attraction network. For the feature attraction network, we are going to use LessNet. And then we remove the detection layer original available in the LessNet. Okay. So as what I mentioned before, that you are allowed to import any neural network from ONNX. If you open ONNX module, you can see there are a lot network that might not available in the MATLAB, and you are allowed to import them into the MATLAB for your application. However, LessNet 50 is available in MATLAB. I just want to demo for you to see how to load the model from ONNX into MATLAB. So let's say you're going to load ONNX into the MATLAB. So you can see I use the function called import ONNX network. So there's a model called model ONNX in the folder. Okay. And the classification, this is a classification neural network. And the class name is this. So the class name basically is just like the 1000 objects that original been built for the LessNet 50. Let's run this. me open another MATLAB to run the application again. I think encountered some technical error that my MATLAB is crashed due to some unknown reason. Yeah, sorry for slightly delay due to technical error. Please grant me another few minutes to complete the setup, and then continue our presentation. Here you go. So, okay, let's run again the example. On this time, we don't import the model from ONNS. I think it consumed too much computing resources for my PC since I'm also open the allow application in my PC now. Let's run again what we did just now. And thanks for your patient waiting. Okay. So load the data set once again. You can see, like, let's say you want to run each of the session, you just double click on the toolbar, then you'll run the session for you. Right, here you go. Then we go to the next step, like to break the data into the testing dataset and training dataset, 50% for testing dataset and training dataset, and use a function image data store to store the location of the image and the information for the label box. Okay, and then combine them, the image train and the label box data store into the training data store. You're not going to export data once again since you have had done this part. Just bear in your mind that now we are going to design the neural network for the sub network for the features attraction network and the detection network. So originally, I want to import the neural network from the ONNS, but I feel that it might consume too much computing resources for us. So now we just load the second part, load our base network, which is a LessNet 50. All right, the neural network is here, so-called BaseNet network. And the next step, you are going to remove the detection layer in the LessNet 50. So over here, there's some information for you to see. A good features attraction layer for the YOLO V2 is the one where the output features width and the height are between 8 and 16 times smaller than the input image. In this case, the input dimension is 224, 2243. So search for something that is around, the parameter is around 16 to 40, which is like 8 or 16 times smaller than 224. So let's open like Deep Network Designer to analyze about this. Here you go. As mentioned in the slide, Deep Network Designer is a iterative apps that allow you to design your neural network or import your neural network for visualization. Here you go. So we are going to load the network from the workspace. So just double click on this import the network for the workspace. So, so import our network from the workspace. Here you go. So it's a very complex DAG network. So as I think my MATLAB is relatively slower than normal day, so I will speed up some of the steps. So now we are going to remove some of the layers. We want the output layer to be like either 14 or 16. So how can we analyze where's the output layer that meet this criteria? So you can put analyzer. So it's going to help us to analyzing the network and the size of the individual of the layer and also the hyperparameter, the amount of the hyperparameter for the individual layers. So let wait for some time for it. Then you will remove the detection layer and then later replace the detection layer with our own design YOLO V2 detection layer. If you look at the simple example, then actually you can use a function to replace all the steps begin done in that I'm going to do, but it's the one is not so deep. The you don't have so much control for your deep learning neural network. Let's say you want to design with more customized deep learning neural network or more controlled deep learning neural network, or you want the deep learning neural network go deeper, then you can see how I design the detection sub network for YOLO V2. Uh, Wait another few minutes for this process. Yep, it's done. Usually it's not that slower, but today I don't know what's happening to my MATLAB and my computer. Perhaps I need to restart again, but it's okay. You still can proceed. And so over here, the interesting point is, as an AI guy, right, you really need to understand what is this activation size and the learnable parameter, the weight and the bias. So as mentioned just now, that if smaller 8 times or 16 times than the input side, so the output will be good enough for YOLO V2 detection subnetwork. So you need to find the value allowed 14 to 16. So when you scroll down, you can see that start from the node 82, it meet the criteria 14 times 14, which is a 8 times or 16 times smaller than the input size of the neural network. But you choose the most last layer of 14 times 14. So you found actually this one. Yeah. Am I right? So after this, you can see like 7 times 7, which is a smaller size. Then what we're going to do is we're going to remove whatever after the node 140. Let's close this. So you're looking for like the node 140. Let me double click on this. So this 110. Go down a bit. 120. Closer to visualize it. 140. So what we're going to do is I will reduce everything here and we design our own detection subnetwork for YOLO. Here you go. So you can either design in a programming way or design in this application, in this geo application. So I will design another two group of convolution layer for our detection YOLO V2 layer. So if you don't do this way, like the most simple way is just drag the YOLO V2 transformation layers and YOLO V2 output layers, and then connect them to each other. But I would like to my neural network go deeper. So what I'm going to do is I'm going to design the neural network, the detection layers deeper a bit. So YOLO followed up by like maybe batch normalization layer. And then again, maybe Lelu layer after this. So you can combine them. Yeah. So after node 140 actually is your detection layer. Okay. Just combine all the. Yep. And the information that you are going to specify is these last three layers. Okay. So you need to change like the number of filters and the number of the anchor bosses and the anchor bosses, the dimension. So I'm going to tell you what are they. So let's go back to our script. Other than design interactively way in the GUI application like the network designer, you can design in like programming way. So over just now I only put one group of this convolutional 2D layer, batch normalization layer, value layer, but in programming way they are going to put two group. Okay. So let's run this session. So the filter size is 3 by 3 and the number of filter is 1024. So you can see this one, they have a two group of convolution layer. So this is the first group, this is the second group. And now we are going to define the anchor bosses. So anchor bosses is to define to capture the scale and the aspect ratio of a specific object classes in our image. So you need to roughly estimate how big your object in the image. So we are going to define 4 rough estimation of anchor bosses. So this is like width, this is height. You can put more if you want, but let's say you put more, then you will run longer in your application. You will consume more time to train the YOLO V2 neural network. And the number of predictor per anchor, I put 5. And after that, you create the After the YOLO layer in the detection subnetwork, then you will transform this into the YOLO V2 transform layer and YOLO to output layer as a, so the last three layers of the YOLO subnetwork is always convolution to the layer, YOLO to transform layer, YOLO to output layer. And the output size is determined by your number of angle. So over here, you calculate the number of angle, number of prediction per angle that you are going to do, and number of classes. Then he decide the last convolution to the layer. Let me run this first. If you look at the simple example, actually you don't see so complex way to design the neural network. That one is relatively simple, but you don't have so much control and about the neural network. Here you learn how to control the neural network and how to build a deeper neural network to train our application. Okay, then after that, I combine the features extraction sub neural network and the detection YOLO V2 layer into this. I'm not going to analyze them because you'll spend some time to open the analyzer tool. So actually the name we change to the base network. I think I might need to export out from here first. Okay, perhaps I missed one part in the script. There you go. Back to the LG. The base network is the neural network that we haven't removed the detection layer. Choose back to this. So after that, you can specify the hyperparameter. So here is a few selection for the hyperparameter. So important are like mini batch size, initial learning rate, and maximum epoch. So people, you always try and add these three different combination of hyperparameter to find out the best neural network. Okay. I'm not going to do the training today because you take a lot of time. So I will just load the trained neural network that you have go through all the process exactly the same. And finally, we get this neural network. Yeah, you are running out of the time due to the technical error that I encountered in my MATLAB. So let's stay with me another 10 minutes. I will try to finish up my presentation in 10 minutes more. The next one is after you get the trained model, which is a detector, then the next one you're going to test the accuracy. So over here, you just randomly to test the one of the testing data set, the image in the testing data set. For example, you want to test the number 7 image in the testing data set and see how its accuracy, the YOLO V2. So the YOLO V2 will return you the confidence level of the detection. Is doing the detection. So if you look at the, okay, now is insert the boarding box on the image. Here you go. So you can see the detection result and the confidence level is around 0.89. So the maximum level is 1. So this I'm going to scan through all the image in the image dataset and come out the result. So one of the important evaluation metric for YOLO V2 or any object detection is they use precision recall curve. This is very important. If you want to evaluate the performance of your object detector, this is one of the performance metric that you really can consider, precision recall curve. So you just Google it, take a look about this, how to use a precision recall curve to evaluate your performance of object detector, and then you will get a lot of information about this. Okay, let's go back my presentation to quickly finish up them. Sorry for the delay due to the technical error. So you go to the part 3. So deep learning models have to be incorporated into a larger system to be useful. Consider like automated driving. There's a lot of algorithm work around like perception system, designing a perception algorithms that can collect the data from multiple sensors and fuse those data into the understanding of what allows the vehicle. But for those algorithms to be effective, they have to integrate with algorithm for localization, path planning, agent, environment management, and controls, all working together to make sure the vehicle accelerate, decelerate, brakes, and steers perfectly in any situation. This can be accomplished with an overall system simulation that handle not just the perception algorithm, but the entire vehicle itself. For example, you have a vehicle object detector in the front camera mounted in the car. Then the object detector detecting a car is 1 meter away from our car. Okay, but actually you can fuse with the result from like radar and lidar sensor. So you have 3 detector. One, the vision detector, the object detector, the second radar detector, the third is a lidar detector. Then you fuse, combine the decision of 3 of the detector and come into the conclusion. You are allowed to do that. Other than this, in MATLAB, you can draw a different driving scenario. For example, different weather condition, different environment condition. You can draw a pedestrian like walking across the road, and then you can test your algorithm whether your car will stop if they recognize a pedestrian walking across the road. You can drive the simulation scenario like this and to test your algorithm. And for the last part is a deployment. You got a unique code generation framework that allow you to deploy to the CPU, hardware board, GPU hardware board, FPGA hardware board. So will help you automate to generate the MATLAB code, convert them to the C and C++ for the CPU hardware board, Intel, ARM, and etc. So you also can help you to generate the GPU code for NVIDIA and the Intel GPU board. So we also can help you to generate like HDL code, FPGA code for the Xylene and the board. Okay. So you are looking to deploy your application to the hardware at the end. You are welcome. You are welcome to talk to us. Then we will give you more insight on or provide the workflow for you to see. Other than the hardware board, you also can generate like IT system, desktop application, web application, and integrate with like databases, cloud storage, or the dashboard, the Power BI Tableau, or put your neural network in the container to save the space and the resources. Yeah. Personally, I'm working heavily in to integrate MATLAB AI or algorithm with IT infrastructure for enterprise system. So to me, if you have any thought how to implement thought or want to know how to implement MATLAB algorithm into your IT system, or you want to create a desktop application, web application, yeah, you're welcome. Talk to us. So due to the time constraint that I'm overrunning the time about 5 minutes now. So I'm not going to present how to walk through this code generation part. But I want to give you some hints. Actually, you can use like MATLAB Coder, GPU Coder. They are in GUI. You just open the MATLAB Coder, GPU Coder, and then insert the function in. Then the GUI application will help you automate, generate the the language, the code that you are desired to get. For example, you have to generate the C language, C++ coding. So you no need to manually translate by yourself to C and then put into the machine. And to summarize why MATLAB and for deep learning, why MATLAB for deep learning? MATLAB is focused towards the engineering and the science workflow. And MATLAB is more productivity because you provide a lot of GUI and a function that shorten your time to develop the algorithm. And MATLAB can deploy anywhere. You can deploy on the hardware board, you can deploy on the cloud system, and you can work with the open source like PyTorch, TensorFlow, Cafe, and etc. And most important thing, you provide support, the human support as from the experienced engineer, sit down together with you to assess your application and how to enable to use MATLAB for your workflow. And let's say you want to download the demos that you see here today in the seminar, you can visit this link. This link actually is in the GitHub. So just remember to star the content, to give a star for the contents if you like. Yeah, we evaluate your feedback on our presentation so that we can improve in the future. Yeah. So this QR code, my marketing will send to you after the seminar. So I'm not going to stop here for few minutes for you to scan through the QR code. So my marketing will send the evaluation form to you after the webinar. So we appreciate your time to fill the feedback to us. Actually, there are a lot like free training online. For example, the MATLAB online, deep learning online, simulate online, stateful online. You can go through them to learn the basic of the MATLAB, the basic of the deep learning, the basic of the simulate and the stateful, and they are free and available online. So let's say you are looking for like hands-on workshop or formal training classes, you are welcome to talk to us. You can customize the class for you if necessary. We also provide consulting services. So talk to us. Let's say you are looking for consultation. Yeah, and don't remember to follow us on the Facebook and the LinkedIn. Let me see, is there any question from the chat box? Oops. If let's say you have any question, you are allowed to ask now. So I will stay here for another 2-3 minutes. If you have any question, please type your question in the chat box. So I will answer your question accordingly. Just for information, actually MATLAB, there's a function that help you to automate design the YOLO V2 neural network. So you just to tell the function that what is your base network. So you just tell the function that your base neural network for features attraction is like maybe LSNet, LSNet, and etc. And then the number of the anchor bosses and the information of your anchor bosses, the width and the height. You just put inside the function, then the function will help you automate translate to the YOLO V2 neural network. There's a question asking about are there applications for steroid classifier for object detection? Yeah, definitely there is. So there because it's based on the creativity, so there are a lot of different approach. Some people do have like steroid camera, then they will stitch the two images together first through the image processing method, like stitch to steroid image, then stitch the two images together, and then after that they will only perform they will perform like the depth estimation. Then from that estimation, they know roughly how far the humans stand in front of the camera. Then they start to do the object detection from it. And another approach that you can look for like multi-input. Okay, so deep neural network accept multi-input. So you can put one input and the second input. So the first camera image is a first input, the second camera image is a second input to a neural network. And that come out with one output. Yeah, it's still possible. You need to play around with the neural network architecture, but a lot of testing required. Can we have the recording session after the webinar? Yeah, I think my marketing will send the recorded presentation to you after this webinar. Yes, for sure. So if let's say you got any question, you can ask. You can send the email to us after the webinar. We are willing to help you, and we'll take our time. There's one question. I'm using Deep Network Designer for my project. I did not do any coding. I just arranged the block diagram. After that, I analyzed to see how many parameters. Then I feed the network with my image dataset. Is that correct? Yeah. So today is a bit complicated compared to the normal image classification. Then because today our application is object detection. So let's say you want to do image classification, like you can do them completely in the Deep Network Designer. No coding at all. And at the end, you can generate the MATLAB code that begin done in the Deep Network Designer. Yeah, it's pretty cool. So you just open the Deep Network Designer, then you import, for example, the LSNet, or you design the neural network by yourself from scratch. Then after that, there's a button for you to import your data, your image dataset. Then after import your image dataset, you allowed to do augmentation, like to flip the image, to rotate the image, to generate more image. And then after that, you can specify the hyperparameter setting, then train the neural network, and then export the neural network out. So let's say you want to generate the MATLAB code that begin done in the GUI, you are allowed to do that as well. So yeah, I hope my information helped you. Yeah, if you are interested to know how to do it in detail, then actually we have a webinar. I conducted a webinar before about how to do image classification in 5 steps in Deep Network Designer, include together with an experiment manager. So you can request a recorded webinar video for my marketing. I think they are okay to send the recorded video to you. Yes. So so let's say you want to know how to use a Deep Network Designer in details. Kindly request the recorded video that I conducted before in the webinar. So you just kindly request for my marketing team. They will send the recorded video to you to teach you how to use a Deep Network Designer in details. How do you do the hyperparameter training options? Yeah, this is a very interesting topic. There's a question asking about how to tune the hyperparameters training options. So there's a very interesting question. So in general, in current practice, most of the AI engineer, they are doing this try and error. So that's why the experiment manager come into the picture that allow you to try and error. So basically, you just try the learning rate 0.001 and try another learning rate 0.001. Yeah, this is a try and error approach. But nowadays, people also come out optimization algorithm to optimize the hyperparameter. For example, like Bayesian optimization. But it still cannot give you the best combination, the best hyperparameter. But it will roughly give you because he might start at the like local maximum, local minimum, local maximum. So it's not fully optimized, which is the global optimization. So try and error might be still the best approach today. if you don't want to try and error, you can consider like Bayesian optimization to optimize your hyperparameter. So there's a question about, could you explain again why object detection require coding while classification does not? Actually, object detection does not require coding. So you can design everything in your MATLAB, the deep network designer. So actually just now, I just want to explain that you can do it in the app designer. You also can do it in the coding. So, but object detection doesn't have any pre-trained neural network, network like normal classification, image classification did. So like for normal image classification, like you can directly import the LSNet and then remove the last 3 layers and replace your last 3 layers, then you can do the image classification. So for object detection, like you import the neural network in, then you need to look for the optimized output layer. Then you remove the layer after the optimized output layer and then put your YOLO detection subnetwork in. So actually all of this you can do in Deep Network Designer for sure. Yeah. Yeah, my marketing team, your take the initiative to email you after the webinar. So after that I believe you can get the email address. Yeah, so after this webinar, they will take the initiative to email you the material about this webinar. Then from there you can request what are the material that you want to look for, you wanted to see. Okay. I think that's all for today. If you have any question, you are welcome to ask me through my marketing. See you guys and have a great lunch. I apologize that my MATLAB a bit slow just now, and I figure out what's happening. Yep. Thanks guys. Have a good lunch. See you. Bye.